Hi, welcome to the part 2 of our data training on Introduction to MATLAB. So today we'll be looking at MATLAB script. Script is similar to recipe. Think of MATLAB script like a recipe for a computer, just as a recipe tells you step by step how to make a dish. A MATLAB script tells the computer what step to follow to perform a specific task or calculation. In a MATLAB script, you write down a series of instructions in a language that the computer understands. This instruction can include mathematical calculations, data manipulation, and other operations. The script can also use built-in functions or commands like MATLAB provides to make certain tasks easier. Once you've written your script, you can run it in MATLAB and the computer will follow the instructions. This can be useful for tasks like analyzing data, solving equation, creating plot or graph, and so much more. So in essence, a MATLAB script is like a set of instructions for the computer to carry out a specific computational task, just like a recipe guides you in making a particular dish. Let's quickly access script environment in MATLAB. So, when we open our MATLAB, this is the first interface we see. Now we would like to navigate and see how we can access the script files in MATLAB. So, in our previous video, I explained to you what a ribbon is and a toolbar is. So when we go to our ribbon, we quickly go to the Home tab, and there we find the New Script and New Live Script. So these are the files that enables us to use MATLAB script. So I'll simply click on the New Script to create a script. Now, this is the script environment. This is the traditional script. When I want to go back to that same place where I selected the script file, I'll come to the Home tab again, and then I can click it to create another script. Now, this is what we call the live script, which we are coming to understand the difference between the traditional script and the live script to see the basic differences. But for now, for you to access the script file in MATLAB, you simply come to the Home tab and click on the New Script or the New Live Script. We quickly see a clear example of a particular function we can implement. Okay, before then, let us quickly look at why we prefer using scripts over the command window. So 1. Reusability. Scripts allows you to reuse your codes for similar tasks without retyping commands. 2. Readability. Scripts provide a structured and organized way to present your code, making it easier to understand, modify, and maintain. 3. Debugging. Scripts makes it easier to understand, to identify, and fix errors as MATLAB points to the specific line where an issue occurs. 4. Documentation. Scripts enable you to include comments explaining the purpose of each section, aiding both yourself and others in understanding the code. 5. Version control. Script facilitates the use of version control systems like Git, helping manage changes and collaboration more effectively. These you can see the significance when you are dealing with model development and any other form of algorithm development you want to do with MATLAB script. So a script allows you to carry out version control or facilitate the use of version control. Now we'll quickly dive into a simple example we can implement. Now you have an example here, a simple engineering tax function, and to calculate the voltage across a resistor. For the electrical guys, you might see this useful for your task, and a basic example of the engineering task you normally carry out in circuit theories. Now, we want to calculate the voltage across a resistor. Now, I would like to automate my system to do this whenever I need to use the calculator or the function. So this is a simple code. What we see here is what we call comment in MATLAB. So this is a single line comment. It explains what the line of code is all about. So here, these comments are not being, they are not part of the code or the function that is being compiled, is not being is it's not, it does not affect our code. Let me just use that word. It does not affect our code when running in MATLAB. It just explains, it tries to explain what we want to do or what a particular function is doing at the time. So now in this scenario, this comment is trying to tell us that we are carrying out an engineering task, which is to calculate the voltage across a resistor. The second comment defines the known values, which is current 2.5. Then the next line of comment tells us the current in amperes, which is supposed to be part of the line of the current equal to 2.5. It's not supposed to be down, it's just an error, a typographical or it's just an error, but we'll adjust that once we continue to implement it in the script. So then we have the resistance value to be given as 10 and resistance in ohms and the voltage is given as current multiplied by resistance. So we're going to look at how we can implement this in the MATLAB environment. So we'll go to our MATLAB environment and see how we can go to our home tab and click on new script. Okay, so we've put our comment. We'll start with our coding. I'll start with a comment to explain what I want to do. Okay, engineering task, calculate the voltage across a resistor. Okay, so correct. So the next thing is, instead of putting the value of the current here, I would like to use one of our earlier function that we stated in our previous video, which basic functions in MATLAB, the input function, the input command. So we're going to use it here. So I will say my current um, current value. I'll just declare my current. I'll select my current. Remember, I told you that when we want to declare, when declaring a particular variable, it's like a container to hold something for us. So the current is like a container, and I want it to hold the values of current. So I will now say input. I'll call the input option, and I will say uh, okay. So input, I'll type input the current value. Now this is the syntax when I want to have multiple string, when I want to call, when I'm having multiple strings. So this is the syntax to use when carrying out the input function. I will first of all put in my my string that I would like to display, to prompt the user to know what actually I'm requesting for, which is for him to impute the current value, and then followed by the the, the space to put in the value. So remember, I told you that I would like to suppress the output, so at that point I will suppress the output within the semicolon. Then I will just give try to explain what this line of code is, which is to impute the current value. Then I will go to the next line of code, which is impute the resistance value. Then I will declare a variable called resistance, which will be equal to impute impute the current value, and dot close the brackets, and that is that. So okay, I think I have a little. Okay, so okay, I think I need to do some corrections. So impute the resistance value. You can give space. You can give space to everything. Okay, so I suppress the input, and then I'll carry out the calculation. Comment calculate the voltage. So now you need to know how do you calculate the voltage. From the knowledge of the circuit theory, you know that voltage, according to Ohm's law, is current times resistance. So I'll just write the voltage is equal to current, my defined current, which is here, my defined variable, which is current, which is here, the container that is holding the current value, then my multiplication, remember the basic arithmetic or mathematical operations that I explained in the earlier video. Now they are all being used here, times resistance. So, and if you notice, when I specify the variable correctly, it highlights the variable which was already defined. Now when I click on this, it highlights, but what if I didn't define it correctly? Now you notice that okay, I remove this E just to see if it will highlight, and I remove the C. So you see, it doesn't highlight because I didn't define it correctly. So this script is kind of more user-friendly because it helps you to see that what you're doing is actually correct. So I'll make sure I'll go back to the way it was. So now you can see it's highlighted and correct. So I'll separate the output. Then I'll use my display function, or I can use my display function, display, and remember when using display function, it's display functions, the element of the display function are all strings. So I'll need to convert my voltage, because my voltage are in numbers. Whatever I'm going to calculate here is going to give me in double data type, so I need to convert them to string. So I explained this in the previous video, converting different data type and why we need to convert data type. So first of all, I'll say the voltage across the resistor is this. So then I will say num to str voltage. So this is very smart. This environment is very smart. It quickly identifies the variable I'm trying to use. So I think that is that. So then I can try and run my code, but for me now to be able to reuse this script whenever I need it, I don't need to come over again and start typing this bunch of code because I just want to calculate the voltage across the resistor. So I will save my code and save the script so that whenever I need it, I can just open the script and run the code and do whatever I need to do with it. So I'll come to this place. You can see save. So I'll click this arrow down here. Then I can choose to save it anywhere. So there's different between save as, and save all, and save copy as. So I'm going to show you what save is. Save means you save it in the current directory. That means the file which I am using called eng underscore map. Sorry, this is the folder example. The folder is example, and so if I want to change from this folder called example, then I will come to I'll come to save as. So it will help it will help me to change, to navigate to different places where I would like to save it. So I'll click on save as. Okay, so it's just like you saving documents in other folder. So I can now choose to go to my documents, then possibly I have a MATLAB folder, so I'll just try to search MATLAB folder, then I can now save it with anything. So I can save it, but take note please, whenever you're saving a MATLAB script, it does not accept space in between the name of the file. So I'll give you a practical example. I will say this is voltage. Okay, I already have voltage calculator, so I'll say this is a voltage calculator, um, voltage calculator with a space, so that you see what I'm trying to say. So voltage calculator with a space, and see the result. You see it prompts error stating that this is not the right format to save your work with. So I can choose to use an underscore here. Okay, so when I save it with an underscore, it will save. That is it. So it has saved the work using an underscore. Okay, so we need to take note of this whenever we are carrying out our saving um, command. Okay, so now I would like to run the code and see if it works out. So I'll come to run. So you see the first thing that is asking me here is impute the current value. So it has executed this line of code now, which is impute the current value. So I can say the current value, probably I know the value of my current flowing in my circuit. So I'll put 6. Don't put 6 amp, just write the digit 6. Now it says impute the resistance value. So the resistance value, probably I've used my meter to measure the resistance, and I will just or the resistance, or use the color coding to get my resistance value. So I can say the resistance value is 10 ohms. Okay. Now you see it says the voltage across the resistance is 60. So this means that it has carried out the multiplication of current and resistance. So 6 times 10 is 60. Now this is just an example of what a script can do. Now for me to reuse it, I'll simply save the work. Okay, I need to save this. And just save the work here. Here, so I'll close it. And then if I want to access the script again that I just used, that I just created, I can simply go to open. You see open, so I'll come to this open folder, then I will locate my document, go to MATLAB, my folder MATLAB, which I created myself, and you can see all my work here. So the one we just created was the one we created last was okay. The extension which we need here is a.m5. Okay, we're looking for our .m5. Okay, alright, so let's say we have our new scripts. Okay, we want to the document, come to MATLAB, open, Okay, the items we just saved are not showing. Let's see what's the problem. Let's see what's the problem. Okay, okay, MATLAB voltage regulator. Okay. Now, what I actually want to show you is how to easily locate your file, not this shortcut where we can from actually locating the file, which we can supposed to be accessible. Uh, Okay, okay, I will troubleshoot that, and in a subsequent video I'm going to probably fix one or two and then show you how you can use the open tab effectively to locate your work and open. But once we go to the file menu, okay, in our document, we open our document folder and we type to MATLAB. Okay, this is the MATLAB folder where we save the work, and okay, okay, so we have it here as voltage calculator. Now, okay, let's see if it appears in the workspace. Okay, maybe I didn't get the title earlier. So okay, so we come to the open tab. And we go to open, and we navigate to the document folder, and we come to the MATLAB folder. Okay, then we can see it here. Okay, it is here, which is the voltage calculator. So I can just simply click on it and type open. So now it is open. See, my document is saved, everything is intact, and I can now click on run again. Now it has prompted me to impute the currency. You see, I don't need to start writing the code all over again. Everything is there, it's just for me to put in my input parameters and get what I need. And so this is just how the script helps us to make our work easier and faster. So if you have a lot of voltage to calculate for a circuit and you have the current and the resistance, what you just need to be doing is to impute your voltage, current value, your resistance value, and you get the voltage. Okay, so now let's just look at what the live script is all about. So I've made a live script already. I had initially created one, which I will just open for us and explain. Okay, so come to open, and we go to document. I choose to save mine in document because it is easy for me to access and all the details I need. I would like my document to be in a particular place where so that for proper management and easy accessibility. So you can choose to save yours anywhere that you feel is okay and you would like your script to be there. So this is a app script thing. We're going to see how it is. Okay, need to wait patiently for it to open. Now we'll open it again. Okay, so come to documents. Okay, this is done. When it comes to documents, MATLAB. So MATLAB action. Okay, this is it. Okay, okay. Uh, Firstly, we need to go to home and create a live script, right? Then we come back to the open file. Okay, we come back to the open file and then we go to documents, MATLAB, and live scripts. It's taking a lot of time to okay. Okay. So we simply create uh, we just start afresh. Please something is wrong with those files and so please just start so to just for us not to waste much of our time. So now this is what we call a live script. Okay, so for me to create a live script, I'll come to the section and just click on use live script and it opens. So once I create a live script, now the live script allow me to have multiple, probably I have different functions. I want to calculate the area of the cycle. I want to have a function that creates the area that calculates the area of the cycle and the area of the square, the area of a rectangle. I can put them all in the live script, and the code will run from after calculating the area of the cycle. I can now choose to go further and calculate the area of the square. So that means I can put different sections of code in the live script and I can only put lines for comments for words or text to explain in details what my code is. Most guys that are into data science and data analysis prefer to use live script because it makes their code look more presentable, especially when they are to present their findings and insight to um, the team or to whoever they need um, that the task is meant for. So now let us look at a quick example of how we use this live script. So I can just simply copy my data here and come to this place and paste. Now this is just like a section in the live script. Now this task is for calculating the voltage drop or voltage across the resistor. So after I've done this, I can choose to put a section of the text to explain further. I'll say this code is for calculating the voltage across a resistor. It is useful for it is useful when there are a lot of resistance voltage drop to obtain. Now, this is what I mean by the, um, having features where you can put in comments or word or text to explain your code. So after this, I can put another line of code. You can come to this place where you see text under the live editor to yes tab. So you can come, you see in the live script, you have files, navigate, text, codes, and different sections. So for this text section, I have I put my text. So once I put a text, I can put another text. The next thing that I can do is to put a code. So I'll put code block to put in another thing. So maybe instead of calculating current this time, I can put in a code and I'll say I want to calculate okay, instead of calculating voltage now, I can change the code to calculating the area of a square. To calculate, I can now say engineering tax, calculate the area of a square. So input the length value, then input breadth value. So I'll change this to length. Okay, just leave to editing just for you to see how it works. Length, and this breadth. Okay, code is looking nice. So as I said, the area of the square, the area of the square is this. So I'm no more having voltage as a variable, so I'll change it to, okay, I've not edited that. So area is length times breadth, right? Okay, so I'll come and say breadth is the number to string, so breadth. Now I can now run this codes by section. Okay, so I will run this first, and you can see. Let me clear this window so that we start everything afresh, right? Oh, mistake. Okay. All right. So we deleted the word. Okay. Okay. Now this is what I wanted us to use, and somehow magically it appeared when we've gone far. So okay, we can still use it. This is the first line of code. Okay, and in this code we have we are maintaining the same scenario here to calculate the voltage across the resistor, and this is the first block. and I had a text. Then the second block of code, and in this one it's just the display function that in this one we used the format print function, and then in the second one we used the display function, and in the third one we used a display function but with a different with content element. Here we use the numbers to string, and here we just choose to use the variable directly without using number to string. And then here we use the format function or the format string function, which I earlier state this basic function in my previous video. So if you've not watched that video, I will advise you to go through that video so that you know what we're talking about. So now, when I choose to run this video, the reason why I tried to created this function was for me to show you the actual difference between the format um, print function, okay, and the display function, and why we always try to convert our numbers to strings. And in a scenario where we didn't convert, what are we going to obtain? So I'm going to run this code for this our voltage across a resistor calculation. So I'll just simply press run. Now, when I hit run, here it says impute the resistance value. So I'll put maybe any, let's say 20, okay? Then impute, okay, I'll need to try and, okay, alright. Let me reset the code again so that, let me just reset this code so that we can have a good, outcome. Okay, now, okay, now, okay, so we're going to run this code and see how it works. So when we run the code, the first thing it asks us is the current value. So we put 20 amps, the resistance 300 ohms, and so the value, the current value is given to be 600 volts. 600 volts. That is what we calculated. So uh, going further, that is for this line of code. That is for this block of code. Then we go to the second code, which is this one, and in the same vein, it says the current value, because what we want to do now is to see the difference between this type of format print function, how it works, and in the scenario where we choose to use the display function. I just want to use this to just try and clarify this at the same time. So now, in this function, we choose to omit deliberately to omit the um, num to string and see what will happen. So we're going to use the same. Okay, let's change it to 30 as the current and then 40, and see if it gives us. Now, what you notice is the voltage across the resistor is, so it didn't give us what you actually want. It didn't give us the value. Now this is because the syntax here is actually not complete. So when I choose to make this complete by putting the nums to string, now okay, so we are at the box now, so I can put in um, 20 as a current and then 300 see. So you can see now it gives me the voltage across the resistor to be 600 volts. Now, so you need to always take note of your syntax. Ensure that what you're doing is correct, your syntax is in order, so that when you're running your code, you avoid errors. Now, you can see the difference between the traditional script and the live script. In the traditional script, you cannot put other blocks of code. You can just maintain one sheet for all your code and run it all at the same time. Or here, I can choose to run the code at the same time, or I can use the step run, and it will run it step by step. Okay, I'm here right now. It has run this code. Then I can choose to step in further. So it has gone to the second code to run. So that is how I can choose to run the code I need to. I want to run step by step instead of running them at the same time. So this is just a quick overview of of how the MATLAB scripts are and why we utilize them that much. So back to our theory, we can look at the basic differences. A script is a simple text file with a sequence of MATLAB commands. A script is executed in a batch mode, meaning that all commands in the scripts are executed sequentially and the output is displayed in the command window. Scripts are useful for automated repetitive tasks and organizing code. So the extension for the traditional script is .m file. So when we go to our MATLAB folder where we saved all our documents, you can see that you can see the extension of these files. You can see the extension. When I right click, I can come to property, and then I look at the extension of these files. Okay. It's taking time to load. It's taking time to load. I don't know why the system is slow. The system is becoming kind of something else. It's slow. Okay, so come to property. And you can see now, just as I said earlier, okay, this is a .m file right now for the traditional script. Okay, it's a .m file. That was the first script that we created. The extension is .m file. So whenever you want to differentiate between your traditional script and the MATLAB live script, you will look at the extension. Okay, so going further, then look at the live script. A live script is an enhanced version of a script that includes both code and formatted text, as I earlier explained, such as explanation, equation, and visualization in the same document. Live script supports a more interactive and dynamic approach to code exploration. You can see the output of each code section immediately within the document. Now, live scripts are useful for creating documents that combine explanation, codes, and visualization, making it easier to understand and share your code. So the extension for a live script is .mlx, so which you can verify. And this is a live script. You can see it says live script. So let's just look at the extension. And so the extension here is .mlx, so you can easily identify it with the extension. Now let's look at what is the difference between these scripts and the command line. The command line is the interactive interface. If you can recall, whenever we just put in a command, it gives us the output immediately. So in MATLAB, where you can directly type and execute individual commands and gives you a response, that is the command line. And it allows for immediate execution of single command, and it is useful for quick tasks and exploring data and getting immediate feedback. While scripts and live scripts are useful for executing a sequence of commands, the command line is for one-off or ad hoc commands. So now, both scripts and live scripts are ways to create scripts in MATLAB, but they have some key differences as earlier mentioned. They enhance code organization, readability, and maintainability, contributing to a smoother development process. So now, go to functions. Let's quickly look at functions. Now, in programming, a function is a um, self-contained block of code that performs a specific task or a set of tasks. It is designed to be reusable, allowing you to write the code once and call it multiple times from different parts of your program. Functions are fundamental building blocks in programming and are used to organize code, improve readability, and facilitate code reuse. So, just as the example we used earlier, when we say we want to calculate the voltage, when we have it that we want to calculate the voltage of across the resistor, that is a function. That means it is carrying out the function of calculating the voltage across the resistor. You can equally have a function that calculates the area of the cycle, a function that calculates the the the, the, the weight, or let's say the speed of a moving vehicle, a function that does all sorts of things. Any code any program or set of instruction that you have that carries out a specific task is called a function. It must be specific for it to be a function. In the sense that, just as I earlier mentioned, the one that calculates the voltage, we can have another function that calculates the current, another function that calculates the resistance. So all these are functions, and you can match all these functions to solve a bigger problem. Now let's look at a clear example. Now we have a function that that we want to use to calculate the area of an object. It can be a square, and that was the example I wanted to implement. So when we implement this code in MATLAB, it simply helps us to calculate the area of the square. So I will leave this up to you to do as your task. Try and see how you can implement this in a script file, and so that you can use it whenever you want to calculate the length and the area of the square. So while you do this, I would like to give you a quick note. In MATLAB, the display function expects character vector or string as argument. If you want to display the numerical values alongside text using the display, you need to convert the numerical values to strings. The num to str function is used for this purpose. It converts the numerical values to their string representations. Now, let's practice.